Okay, hi everybody. So we are going to do our next topic, second to last topic for the post-spring break material on oxidation reduction reactions. So that's the topic of the video today. Oxidation reduction reactions, it's another way of saying the transfer of electrons in a chemical reaction. So let's take a very simple chemical reaction. Magnesium combines with oxygen to make magnesium oxide. So what we want to be able to do is find the charge on each one of those elements on both sides of the equation. Okay? The charge on each element is known as the oxidation state. So when you hear the term oxidation state, think charge. What's the charge on the element? So with any pure element, the charge is zero. It's just a neutral atom. So I'm going to put the charge here. Charge on magnesium is zero. Actually, I'm going to put it on the top, and I'll show you why in a little bit. So the charge on the magnesium is zero. It's a pure element. Charge on each oxygen atom is zero. It's a pure element. But now we get to a compound, and hopefully you recognize it's an ionic compound. So what charges are now present on each of these elements in the compound? Just use your knowledge of the periodic table on what charge elements typically have in compounds. So you should know magnesium is in group 2, it always has a +2 charge. And oxygen always gets a -2 charge in a compound. So that's a -2 charge. Okay? So now the goal, after assigning these oxidation states or charges, is to figure out which element gained or lost electrons, because that's the kind of reaction we're talking about. So we can see that magnesium goes from being a neutral atom to a +2 charge. So what happened to the magnesium atom to get a +2 charge? Well, it's not going to gain protons, because protons can't be gained or lost unless we're doing nuclear reactions. What's going on is we're gaining or losing electrons. So what happened to the magnesium atom? To get a +2 charge, we would have to say magnesium lost electrons. Okay, to get that +2 charge, we can say that oxygen gained electrons. 2 for the magnesium and 2 for the oxygen as well. So using this terminology, oxidation reduction, whenever something loses electrons, we say it's oxidized. So we can say magnesium is oxidized. And we can say oxygen is reduced. Okay, so that's important to be able to tell which element in a chemical reaction is oxidized and which one is reduced. So we can say that oxidation is defined as the loss of electrons, and reduction is defined as the gain of electrons. Okay? And we can remember that with a really simple mnemonic that we get from Alaska being an oil state. We'll do this, oil rig. Oops. So you can say oxidation is loss, and reduction is gain. So remember which way it goes. Oxidation means loss of electrons. Reduction is gain of electrons. Oxidation is loss, reduction is gain. So most of this lecture is going to be determining these charges or oxidation states, and then in chemical reactions as well. Okay? So we'll erase a little bit here. Excuse me. So another couple of examples. Let's have this reaction. Fe2O3 goes to 4Fe plus, I think I need 2 of these, plus 3O2. Okay, so let's look at this chemical reaction. And first of all, let's assign some charges to each of the elements and on both sides of the reaction. So on the right side, we see now we've got elements, right? So pure elements, charge is 0. Now in a compound, a little bit different. We know that oxygen always gets its -2 charge. Okay? Almost always. We'll get to that in a second. But how do I know what iron's charge is? because I look at the periodic table, it's a transition metal, it's not obvious to tell. Well, there is always going to be one element where we know what the charge is. We can figure out the other by assuming that the total charge on a compound is 0, right? So I'm going to do this. I'm going to break apart the two elements, and I've got 3 -2 charges, so there's a -6. So we know that it's a neutral compound, so the total positive charge has to be a +6. If it's a +6 for all the positive charges, and there's 2 positive ions, then each one of them is a +3. Okay? So now we can look at this situation and figure out what element gained electrons, what element lost electrons. Well, iron is going from a +3 to a 0, so is it gaining or losing electrons? Well, if it's getting less positive, the charge is being reduced, but the positive charge is being reduced, we can say iron gained electrons, and therefore it is reduced. And oxygen goes from a -2, each oxygen goes from a -2 to a 0, so it lost electrons. So we can say oxygen lost electrons, and we can say it's oxidized. Okay, so remember, reduction is gain, oxidation is loss. So what I want to do is give you a little bit of practice, first assigning these charges, and then we'll apply it to a couple more chemical equations. So I'm going to bring over this other board, and here's a bunch of compounds, and I want you to be thinking about how would I assign charges to these things. And there's some rules. So let's look at first HCl. So I'm going to erase this, and we'll work with these compounds here, and hopefully you can see them all the way to the bottom. Okay, and so let's find the oxidation states or the charges for each of these compounds. So again, I'm just going to break it apart. So what charge does chlorine usually have? Almost always a -1. Hydrogen is almost always going to be a +1. So those are the oxidation states. Okay. Now here's a little bit tricky. Fluorine usually gets a -1 charge, right? Oxygen usually gets a -2 charge. So it gives us a problem, because then that would be a -4 charge total for the compound. We know that all compounds have to be neutral. So we have to take fluorine as a -1 charge. That is a guarantee. Fluorine is always a -1 charge in a compound. So if fluorine is a -1 charge, and there's 2 of them, that's a -2 charge total, which means, in this case, very strange, oxygen's got to be a +2 charge. And there's only 1 of them, so we say that oxygen has an oxidation state of +2, a very unusual situation for oxygen. Oxygen always gets a -2, with a couple of exceptions. Number 1, if it's bonded to fluorine, and number 2, in hydrogen peroxide. And we can try that at the end or during office hours. Okay, let's do the same thing for CO2. Put a little line between the 2 elements. Again, oxygen's going to get its -2 because it's not attached to fluorine. So if each oxygen is -2, that means there's a -4 charge in the molecule because of the 2 oxygens, which means that I have to have a +4 charge in the compound because it's got to be neutral. So that means, in this case, carbon has got to have a +4 charge. Again, these aren't ions, these are just oxidation states. It's a little bit different than an ion, okay? But it's going to help us understand where electrons are getting transferred to and from. Okay, so let's go back to hydrogen in the methane molecule. Okay, so what charge does hydrogen almost always get? Well, it almost always gets a +1 charge. And there's 4 of them, so that's a +4 charge. So in this case, carbon is going to have a -4 charge. Okay. Now here's an unusual situation. Whenever hydrogen is attached to a metal, the metal is going to get its normal charge. Okay, so what charge does calcium usually get? Calcium is in the group 2, so that's going to be a +2. We know that. Those are guarantees in group 1 and 2. That means that I'm going to have a total of -2 in the molecule, and there's 2 hydrogens, so each hydrogen gets a -1 charge. So the oxidation state of hydrogen in this case is -1, kind of an unusual one. Okay, we get to our first ion. How do I deal with ions? Well, in all the other molecules, all the charges have to add up to 0 because it's a neutral compound. In this case, all the charges are going to have to add up to -2 because it's an ion. But we'll do it the same way. Let's put a little line between the carbon and the oxygen. I know that each oxygen is a -2, and there's 3 of them, so that's a -6. And remember, whatever carbon is going to have to add up with -6 to get to a -2 instead of a 0. So what's the number going to be here? Well, obviously 4 minus 6 is -2, so we know that carbon has a +4 charge in that ion. And then the last one, what do I do with 3 elements? Well, just start picking them off one at a time. Do we know what potassium's charge is? It's in group 1, it's always got a +1 charge. What's oxygen's charge? We know it's got to be -2. And there are 4 of those, so that's a -8. We know potassium, there's only 1 of those, and that's a +1. So we're missing the manganese, and we know everything's got to add up to 0 because it's a neutral compound. So what's the missing number there? Well, it's going to be a +7. That's the only thing that makes it work. So we know the charge on the manganese is a +7. So those are the oxidation states. Okay, so let's do one last example of a chemical reaction. And I'm going to have you guys figure out what's oxidized and what's reduced in a chemical reaction. So we're going to do this. Okay, so what I want to know in this example is what element is oxidized and what element is reduced. So what that means is I've got to find out which element gained electrons, which element lost electrons. To be able to do that, I'm going to have to figure out the charge on every single element in every single compound in the equation. So let's start from left. So again, put these little lines in between. Charge on potassium is a +1, charge on oxygen is a -2, and I've got 3 of those -2, so that's a -6. Potassium we know is a +1, and there's only 1 of them. You ignore the coefficient when you're doing this. Don't worry about the coefficients at all. Okay, so there's only 1 potassium in the molecule of KClO3. So what's the missing number here? It's got to add up to 0, so it looks like chlorine is going to have to be a +5. So chlorine is a +5 there. Okay, I'm going to save this one for last because the other ones are a little bit easier. So we know potassium is a +1, we know chlorine is a -1. Okay, how about CO2? Well, let's put a little line between them. Each oxygen is a -2, and there's 2 of them, so that's a -4. That means that carbon has to be a +4 here. And then in the water molecule, oxygen's got to be a -2. So that means I got to have a +2, and there's 2 hydrogens, so each hydrogen is a +1, which makes sense. Okay, so let's go to the C6H12O6. How do I deal with that one? Well, I know that oxygen is almost always -2. In this case, it is. It's not attached to fluorine, and there's 6 of those, so that's a -12. And then what's the charge of hydrogen? Well, almost always, unless it's attached to a metal, the hydrogens are +1, so that means I've got a +12. So what does that leave for carbon? What am I missing? Well, if it all adds up to 0, what's the missing number here? Think about what it should be. What +12 minus 12 equals 0? Well, it's going to have to be a 0 there, and there's 6 carbons. Each one of them has 0 charge. Okay, so now I've got everything labeled. Now I just have to figure out what gained electrons and what lost electrons. So let's look at potassium. Potassium goes from a +1 to a +1. Nothing happened to it. Not oxidized nor reduced. How about chlorine? Chlorine is a +5 on this side. ooh, it goes to a -1 on that side. So what had to happen to chlorine? Did it gain some electrons or did it lose them? Well, if it goes from a +5 to a -1, it has to have gained them. So we can say chlorine gained electrons. And which one was that again? What is gain? Reduction is gain. So we can say chlorine is reduced. Okay, reduction is gain of electrons. Oxygen, -2, it's also -2 there, and they're -2 on the other side. Nothing happened to the oxygen. So how about the carbon? Carbon goes from a 0 charge, looks like, to a +4. So if it goes from a 0 charge to a +4, it must have lost electrons. So we can say carbon lost electrons. Therefore, we can say carbon is oxidized. Okay? All right. If there's any questions, we can deal with this during our normal office hours and Zoom meetings. So this concludes section 4.9, and we have one more video left, and that's section 4.10.